Today I'm talking about the issues that's relevant to climate change, but I think it's more directly relevant to our daily life about air pollution. It's part of it. And I would like to address issues that how scientific challenge and make actually linkage with the policy too. Well, I acknowledge those people who have been contribute to my presentation, and because lots of ideas sort of compiling from the presentations during the workshop in the past years. Well, about 2015, China or Beijing, and also China, first time in the history, released we call the red alert. This is the highest level of alert regarding the air pollution. We know that we have fires, then we have an alert, we have a hurricane, earthquake, or have alert. It's never happened in China that we, for air pollution, we have issues that occur. And then this is also not a media coverage about air pollution. And people are become more and more concerned and worried about why air pollution are hanging on there, even getting worse. So there's a lot of questions asked about how air pollution, especially when we have the red alert. The university, not university, elementary schools are closed. Traffic has been reduced to half. Construction sites have been shut down, and a lot of manufacturing has also to be closed. So this has a large social impact, and also is a cost about this one. Actually, when we're talking about many media's coverage about air pollution, international and national wide, it's just focusing on a few cities like Beijing or Shanghai. But each time we have air pollution, it is much regional wide. So, for example, here, when we have the events in 2013 January, we see from here, if you, in case you don't know where Beijing is, it is here, and here is Shanghai, between about 1,000 kilometers, these two cities. And this wide range area are under high air pollution rate. So this is like a million square kilometers, and 100 millions of people are under the influence of each time severe air pollution. So it's not a city, it's a regional scale. Well, there's a different way China to deal with air pollution. One very important thing is each time we have political events, or Olympics, for example, and the government take extreme measures to control the air pollution, then we see the blue sky. So the APEC summit in China, you said that we see really blue sky in Beijing. We call APEC blue. And I show this one as a background haze, and you see the blue sky. By doing that, I think it's a very important thing to demonstrate that if you take the action, you can control the air pollution. Because many people are getting very much disappointed to say maybe we can live there lifelong and we don't be able to see the blue sky. So this actually, even though each time extreme measures were taken, very costly, but it's very effective to show that air pollution is controllable. It's political willingness and also economically feasible if it can continue measures. Well, when we talk about air pollution, there's so many questions asked, and I put this question into 3 R's. The first, what's the risk to the whole society, for the government policymakers, and for the individuals, how it's impact our own health. And second R is the reason why we have air pollution, and why it's not getting better, or how can we get it improved. So there's a third R, what's the response of society to reduce air pollution. So these 3 R's is mostly, we can put every question regarding air pollution into it. So I will briefly discuss are first the risk. Now we have this international community WHO. They have this global burden of disease to estimate the risk caused by the different factor to human deaths. So they're ranking the numbers of the mortality or how many people die according to different risk factors. Globally, dietary risk, people eating too much or too little, that's the highest risk. The second one, high blood pressure, and tobacco smoking, and around seventh is ambient air pollution. It will cause about 3 million premature deaths globally. So among all the environmental factors, air pollution is the top one responsible for the premature deaths. In China, actually 1/3 of this globally premature deaths happen in China. So we have roughly 1.2 million premature deaths happen in China, and it's ranked in the fourth factors. Well, we did our own study with better quality of data, and we come up with similar results that indicating 83% of Chinese population living in the area exceeding the Chinese ambient air quality standard or noise. The standard of WHO is about 35 microgram per cubic meter. 83%. Globally, it's only 32. That's indicate how widespread air pollution in China. And we come up with similar numbers, 1.3 million. So for the public policy maker, that gave us strong evidence, or indicated strongly that how high the risk of exposure to particulate matter PM 2.5 could cause to the health perspective. And we also using the models, ambient air quality model, to calculate if throughout the whole country, if there's 83 population people living and their air quality improved to meet this ambient air quality standard 35, we can reduce about 23% of deaths. So Canada got rid of only 23. If we tighten up the ambient quality, we can reduce to 25, and even tighter 15, and the most important one from WHO's guideline 10, we still have significant mortality. Well, that indicates whatever China is doing, even though we meet the first level of ambient air quality standard, still a long way to go. And so that gave us how we can expect in the future that we will recommend to the government that continues to tighten up the emission to improve air quality. But story doesn't stop here, because we know PM 2.5 is we call it the matrix of all the particles smaller than 2.5 micrometers. They came from very different sources: combustion, dust, and also the chemical reactions leading to the sulfate nitrate, and there's also black carbon from different combustion source. So different size particle from different source and have very different chemical compositions, then they are mixture. And the question is, because of the mixture of particles, different cities will have different mixture, and their health impact could be different. So I remember that the pies showing the day before that here in Chile you have a high fraction from the copper smelting. Well, this is not happening in China. Definitely, I think unique signature here. And there's some area you have high black carbon or diesel exhaust particle. They're much higher health impact than the other sulfate. So that's the one issue we have to dealing with. If we are able to find the particle that's most pollutant to human health, then our control is much more effective in the sense of protection. And the second one is different size particles deposit in your body in a different fraction. We know different size have different chemical composition, and they may penetrate in the very deep vena cells there, so they cause very different health effect. And how can we differentiate and to control them? And also another issue is when we expose the particles, the whole body responds, not just the respiratory, not just the lung, but our heart, or immune system, or brain. So this accumulating evidence that our whole body throughout our whole life are under the impact of exposure. So how can we deal with that? And finally, different group, people with disease, with asthma, for example, with heart disease, they may be more vulnerable, and they may cause much higher harm to them when they expose, and same as the children and elderly. So different group of different, they may respond differently. So one ambient air quality standard cannot be satisfied in the sense of protecting the different group. So that's the challenge, I say, for the policymaker and for the scientists to identify which components from which source and cause which kind of health damage to which group, and then we can able to prevent the health effect more precisely and more effectively. Well, second is reason. There are so many reasons. In China, we are very unique geographically. In the eastern part of China, we have usually joint line from here to here. This is the eastern part of China. It's more developed, high population density, and all this industry emissions with the high population density and cause a very active photochemistry and leading to the formation of smog. So that's the area. But we have also dust from the western, like Gobi Desert, and then they can mix with our air pollution and have a certain kind of chemical reaction, and then transported to Seattle somehow. California. Yeah, you saw that, right? Yeah. So this is how we have Tibetan. That is same as Andes. So high mountain, high UV, and it's an exciting area to do the research there. And if you want to drink ice core, there's many glaciers too. In China, we have the energy system at mostly 60 to 70% from coal. So coal combustion emission is a major contribution, but in the meantime, in the cities, we have the gasoline. So coal caused the pollution is more like a London type pollution in 1950s or even earlier, and vehicle emission more like Los Angeles since 1940s. And in China, because we have such a fast economic development, we have these two types of pollution happening in the same location, and so it makes it much more complicated. So we call a complex of air pollution in China, and it's also much big challenge to deal with that. Has government done anything to control air pollution? The answer is yes. If you look at the trend, is since 1990s, the emission per capita actually has been decreasing for the SO2, NOx, CO, and PM. That means a different reason behind that. But even with that, the total emissions are increasing in that sense because the economy is much more faster than the way effort have been done to control them. So there's a different trend of SO2, NOx, nitrogen oxide, volatile organic compounds, carbon monoxide, PM2.5, black carbons, and organic compounds, ammonia, CO2. They have all different trends. Mostly going up. CO2 is good indicator of energy use in the fossil fuel, but you can see very interesting SO2 has a very different trend. It's indicating because China has take SO2 as the major pollutant to control, and the policy wasn't effective until 2005. There's a reason for that. If I have enough time, I can explain for that. But the others, some stable, some more increased. So that's what. This is human activities. How about the nature? The meteorology, we know if I have strong winds here in Xinjiang, you may see blue skies. But you have a stagnant area, you don't. So same like in China, the things we found that generally the surface wind speed are gradually slowing down. So let me see. This is the trend starting in 1960s. We see the average surface wind at 10 meters starting from 3.2 meters to 2.3 meters. The wind speed is slowing down. So that's actually not good for dispersion air pollution. And number of days unstable, we know if the atmosphere is unstable, we have more mixing and dispersion. And the number of days of unstable days are decreasing. Well, so it's much more interesting and challenging. So we also, throughout the whole country, is also a calculation of the case of the stagnant conditions, and the journey is became more and more stable. So atmosphere became more stable. And why is that? There's many studies now we planning because climate change. Well, this is reason and this makes sense. In general, we know the global warming, people said reduce the temperature gradient from the tropical to the polar area. So in China, we're under monsoon system. The monsoon became weaker, and we have less wind, strong wind. There are also certain recent studies said Arctic sea ice. When we know the Arctic sea ice becomes area becomes smaller, and then actually is associated with extreme winter haze in China, and so this is one paper recently published, and also another paper just published a couple months ago on the climate change. They do a long-term study, and they found that the climate change actually associates with the weather conditions favorable for the heavy haze in Beijing. So that's also suggesting meteorology, climate system are also not helping us to improve the air quality. So they come up as a warming boost air pollution, global warming. Well, this is throughout the large scale, and in the vertical, we know the boundary layer meteorology telling us if we have immersion layer, then it's not favorable for the dispersion. And it's interesting to see that air pollution, if we have higher air pollution, will shielding light from the surface reduce the convectivity, and also leading to the formation of more and lower immersion layer. So because like if we have black carbon, more absorbing, and it will cause the temperature higher. So this is another one I think it's interesting to point out. Besides, Beijing as a city. 1 minute? Oh, okay. Oh, I'm sorry, I talked too slow. I was 300 slides. All right, okay, I go quick. And then I think I just gave this regional transport from the other side. It's also important one. And sorry for that. And for the chemistry, this is another important issue. Now we know the radicals in the atmosphere is leading to the formation of secondary aerosol. But we found the OH radical, which we believe usually is major one, and we know a lot of 100 papers regarding that theories have been very mature established. Then we found it actually doesn't hold in the case like in Beijing, that the monitoring concentration is actually higher than the model. So we have found a solution that's unknown recycle process there and needs to be answered. So this radical response for the nucleation of the particle and nucleation leading to the formation of other chemicals, like we know the mineral dust particles now, but we don't know what's happening on the surface of mineral dust particle because it will convert the gas into the pollutants, which cannot explain by the current knowledge. So this is a lot of issues now. So that's the challenge. The complicate air pollution information, the feedback process, and also air pollutant and boundary layer meteorology and profile of the temperature immersion areas. And if you give me another 1 minute, the third R is how the government policy needing to take actions. Well, 2012, February 29, the Chinese government for the first time initiated the PM2.5 ambient air quality standard and require have a nationwide monitoring network. Now, in 2013, we have this so-called action plan, put the target of different region, and this first national air pollution control action plan focused on PM2.5, and it will ask the air quality risk-based reduction. Now the challenge, we need to take a lot of action to reduce it faster. Another one maybe has with policy, set of instruments, the legal system, regulation, market-based instruments, and skip this one. And then there's how to get all the pollutants from all the sources control at the same time to meet target. And because we are setting target by is risk-based and then based on protecting human health, so all the tools are required. And finally, regional transport pollutants, and like Santiago want to control its own, but upwind the other cities are emitting. So how to negotiate the emission control between the cities, that needs a lot of action to be taken. So I make a very brief summary that higher air pollution causes tremendous health impact to the human health and ecology. Understanding scientifically the reason is very critical for a sounding policy, and very challenging, most challenges, the linkage between the scientific community and the policymaker. I think CR2 has set a very good example, and it's good for us to learn from. With this one, thank you very much.